Okay, so starting with line graphs. To set up a line graph, it is similar to a bar graph in that I'm going to have categories and I'm going to have quantities. My categories go across my horizontal column, except now, just like we just went over, our category is our time, because line graphs show me how data is displayed over time. My category is going to be some type of year. And in this case, in example 4, it's giving me the years 1994, 95, 96, 97, 98, and 99. All right? So my categories are my years. Whereas with bar graphs, they were actually, like types of birds or whatever. With a line graph, they're going to be years or maybe even months. And I still start my quantity with 0. But now let's look at the range of the numbers on example 4, 3.2. Okay, well, what's the smallest number of subscribers in millions? What's the smallest number? I'm on page 110, right there. It's 24, right? So what do you think our lowest number needs to be? Okay, it needs to be 20, but isn't that pretty close to 0? Okay, so I could just go 0 to 20. I skip a block, though. Don't squish them together. Skip a block. Then I could go to 40, 60, 80, and 100. Notice how I have a ton of dead space at the top. Do I need all that dead space? No. So let's just go ahead and erase that. And now we've got it set up. But you have to have grid lines. Without grid lines on a line graph, I'm not even going to give you credit for it. So not only do you need horizontal grid lines, but for a line graph, you need vertical grid lines as well. So notice that my grid lines are going straight out of my dates. There is no question that the grid line matches the date that's right underneath it. Okay, so make sure you draw it straight out of the middle of that date. And then you need your horizontal grid lines as well. Now that we have that done, we're ready to go ahead and do our line graph and plot our points. So in 1994, how many subscribers did I have? About how many? About 24. So do your point right around 24. Okay, so hopefully you have a block in between for your 30. So right in between that, about 24. How many in 1995? 34. How many in 1996? 44. Notice a pattern? Okay, now I want you to plot the points on the last 3 years. All right, so now we're on the top of page 116. We're looking at the chart on the top of page 116. We're going to do a stem and leaf plot for this data. And what a stem and leaf plot does is it shows us how data is clustered. Okay, remember how we talked about how data is clustered and we talked about outliers? Anybody remember what an outlier is? What's an outlier? It's a number that's really, really high or really, really low away from the cluster of data, right? We talked about how that sometimes throws off our mean. So with the stem and leaf plot, I'm always going to start with the lowest number in my chart. So what's the lowest number here on the top of page 116? What's the lowest number, lowest speed? It's 32. So my stem, think about a branch with me for a second. So we're going to have an imaginary branch. I used my pen last hour. So we have an imaginary branch and we have all these leaves. Well, if I start picking off the leaves, what do all the leaves have in common? They all came from the same branch, right? So the stem is what all the leaves, the number that all the leaves have in common. So I look at the number 32 and I ask myself, okay, how can I break this number down? What is the number that the other leaves could have in common? And it's the 3, the 30s. So 32, 3 is going to be the stem, 2 is going to be the leaf. Are there any other numbers in the 30s? 39, right? So again, what do they have in common? 32 and 39 both have a 3 in common, right? So the stem is the number that all the leaves have in common. Let's look at the 40s. Any speeds in the 40s? 40, so 4 is 0. Make sure you have a 0 there. What's another speed in the 40s? 40. What's the next speed, though? We're doing them in order. 43. What's the next speed? 45. What's the next speed? 47. Any speeds in the 50s? 50. Any speeds in the 60s? No, so skip it. Because if I write a 6 and a 0, that would count as a number. And there are no speeds in the 60s, so I just skip it. Any speeds in the 70s? 70. So 7 and a 0. And I have completed my stem and leaf plot. But I'm still missing the most important part of my stem and leaf plot, and that is my key. Because how do I know what my branch is dividing? Do I know that it's dividing tens and ones, ones and tenths, hundreds and tens? The only way I know is through my key. All right, and my key, I can choose any number in my stem and leaf plot. I like to choose the first number just because it's easy. And I'm going to say 3 to 2 equals 32. Based on my key, I know how to now, if I'm going to pull the numbers out of the stem and leaf plot, I know how they relate together. It's not 3.2, it's 32. All right, any questions on the first stem and leaf plot? I want you to do your turn now, number 1 on the bottom of page 117. Your turn now, number 1 on the bottom of page 117. All right, so our smallest number we said is 67. So 6 is my stem, 7 is my leaf. Any other numbers in the 60s? 69. So you got a 9. How many people got that first one right? Did you get the first one right? 6, 7, and 6, 9. What about 70s? Any scores in the 70s? 71, 73, 73, 75, 78. Do not use commas. Did you put commas? If you did, erase them, okay? No commas go in a stem and leaf plot. What about 80s? Oh, yeah. 81, 82, 83, 83, 86, 88, 89, 89. All right, what about 90s? 92, 94, 96, 98. Any hundreds? Okay, so just 100. And the 10 goes in the stems, just like I was telling Michelle. What if I had 102 and 105 and 108? What do they still have in common? The 10. Okay, and then the 2, 5, and 8 would be the leaves. All right, what am I missing? I'm missing my key. Did you do the key? 6 to 7 equals 67. And again, did you have to use that one? No, you could use any number in the stem and leaf plot as long as you show that this number to this number equals whatever it is, 73, 78, whatever number you chose. All right. Now, what if you had, all right, so we're going to go on to, what if you had decimals? What if you had decimals? Now, you can do a stem and leaf plot the same way, except now essentially your trunk of your stem and leaf plot, it is now dividing what two place values. Not tens and ones now, it's dividing ones and tenths. Okay? But I don't need a decimal place in my stem and leaf plot. My, what? Starts with a K. My key is going to tell me that it's separating the ones and tenths. So what is my smallest number? What's my smallest number? It's, just tell me. 0.7 or 7 tenths. Okay, so the 0 goes in the stem and the 7 goes in the leaf. Any other numbers less than 1? 0 point anything? 0.8. So that's another leaf. Okay, so over here in my key, how do I know that it's 0.7 and not 7? It's my key. I say that 0 separated by 7 equals 7 tenths. Now I know what place values are being separated by my stem. Okay, we can call it that. All right, any numbers in the ones? Any numbers in the ones? Nope. No numbers in the ones, so I go straight to twos. Any numbers in the twos?
Yeah, 2.1.
All right, 2.1. Any other numbers? Nope. Any numbers in the threes?
3.3.
And 3.8. Any numbers in the fours?
Yes.
Okay, so am I done? Because, and you've got to catch this because it's on your homework and it's on your quiz tomorrow. If I leave nothing in my leaf, does this number exist?
No.
No, it doesn't. So if it's a whole number, what number can I write in my leaf to represent it?
0.
A 0. Because 4.0 is the same thing as 4, right? Okay, so I use the 0 to actually hold that place in my stem and leaf plot. Christopher.
But wouldn't that then make it 40?
No, because my key tells me that my stem and leaf is 1s to 10ths, so it makes it a 4.0. Okay? It would make it a 40 if I didn't have a key, or if my key said 0 to 7 is 7. That's why the key is so important. All right? Any other questions? So now let's go back to our last example here for a minute. Okay? I want you to go back to the very first example that we did, the stem and leaf with the speeds of the animals, this one right here. And now we're going to find the mean, median, mode, and range of these numbers. So you say, how do you do that? Well, you need to pull the numbers. Let's pretend for a minute that we don't have the chart right in front of us. Let's pull the numbers out of the stem and leaf plot. So if I have 3 to 2, I can use my key, and I know that 3 to 2 gives me what? 32. So I'm going to write 32. Somewhere around this stem and leaf plot, I want you to start pulling out the numbers and write a 32. What's going to be my next number? 39. What's going to be my next number? 40. What's my next number? 43. What's my next number? 45. Next. 47. Next. 50. Next. 70. And look, it's beautiful. They're in order already from least to greatest. Okay? So now, how do I find the mean?
You add them up.
Add them all up and divide by
2.
how many numbers there are. Okay, so find the mean and see if you can find the median. All right, so what was my total when I add them all together?
376.
366. And then what do I divide by? 8. Very good. To get 45, and I did correct that, but it's 45.75. So, yeah, let me just erase that. All right, 45.75, and then how do you find the median? How do you find the median? You just start canceling them out, outside and inside. Oh, but what happens? How many numbers do you have in the middle? 2. So what do you do?
Add them together and divide by 2.
Yes, add together and divide by 2, and your median is 44. Do I have a mode? Do I have a number that occurred more than once? So I'd say no mode, and what's my range?
32 to 70.
70 minus 32, which is 38. 38. So 38 would be my range. Now, let's look over to this other stem and leaf plot over here. Did I have a mode in this one? Do I have a mode over there?
Yes.
What's my mode?
73.
73. Any others? Any others that occur twice? 83. Any others? 89. Okay, so I have a 3-way tie for the mode on the Your Turn Now question because I have 3 numbers that occurred twice. What if one of the numbers occurred 4 times? Then that would be the one, right? It would just be, that would be the only one. So whichever number occurs the most, if there's numbers that occur the same number of times, then they share the mode. All right, and if you understand that, that's everything you need to know for line graphs and stem and leaf plots.